Hello everyone, I hope you are doing good and welcome to the channel of Ahid DevByte. Today we are going to solve another interesting problem which is a medium level problem because in the last two videos we solved the easy level problems. Today we are going to solve a little bit challenging but interesting. So we need to find the first and the last position of the element in the sorted array. So array will be already sorted for us. We need to find the first occurrence and the last occurrence of the element and return their positions. For example, there is an array and we have a target of 8, let's say. So what we will do is we can give the position of the first occurrence of 8 and the last occurrence of the 8 and return it. Uh, if in other case, if we don't have a target in the list, for example 6, then we return -1 to both things. So in this problem we will use the popular technique of which are using in data structure and algorithm, which is binary search and divide and conquer approach, in which we can divide this problem into two halves, like left half and right half, and then we try to find our target. Once we achieve the target, we will return the positions of that element we are going to find. Without any further wait, we can deep dive into the presentation where I can explain the problem step by step easily, and then we will figure it out how we can solve it into code. Read the description and understand the problem and objective behind this problem. So first of all, we have a problem given an array of integers nums sorted in non-descending order. Find the starting and ending position of a given target value. If target is not found in the array, return -1 and -1. So what is our objective here? We already have a sorted array. Our goal is to find the first and the last position of that particular element which is matched with the target. So here, what is our expected input and output? For example, if we can see here, this is our array called nums, and it has elements 5, 7, 7, 8, 8, and 10, and our target is 8. So the output will be 3 and 4. Why? Because of this 5 is placing on 0, 7 is on 1, and again 7 is on 2, then 8 is on 3, and 8 on 4, and then 5. So in our case, our target is the first occurrence is on index 3 and the second occurrence on index 4. So we will return their positions. Now let's assume in the second case. For instance, here we have 5, 7, 7, 8, 8, and 10, and our target is 6. So in this case, we don't have found anything in the array because array does not contain our target. Therefore, we will return -1 and -1. So let's now understand it little visually. Here is our array, the same array we discussed in the last slide. So we have 5, 7, 7, 8, 8, and 10. So this is our target 8 and starting point 0, ending point 5. We need to calculate the mid, and we keep repeating the same procedure until we find our target from the both side, from the left and right side. For that purpose, we have a equation like, for example, we have to find midpoint, we calculate the left and right and then divide it by 2 to calculate the midpoint. In this case, we have 0 plus 5, which will be 5, and it will be divided by 2, so it comes up with 2.5. So this operator will give us the whole number, not just pointing value. In this case, our midpoint is ending at 2. So in when we see we have found it 2, in this case, first we try to understand that our target is on the left side or the right side. In this case, if we can see is our target is on the right side. So we will ignore all the left side. For example, if I can arrow it, it will be completely eliminated. Now we can focus on this point, means this section, and we go again for the second repetition. This time we have a midpoint 2 and a starting point 3 and ending point 5. Why? Because we have ignored all the left side items. 8 is point number 3 and 10 is on point number index number 5. So again we will calculate the midpoint of it. Left right means starting point is 3, ending point is 5. 3 plus 5 equals to 2, and it will be 3 plus 5 equals to 8, and 8 divided by 2 equals to 4. And then we will see we have found this targeted array. As we have founded our target, if we can see this mid is 4. Now we come to our array and looking for it. We have a target of 8, so we have found it on index number 4. So this will we will remember it for our occurrence, that first occurrence or the last occurrence for that purpose, and we will keep repeating the same procedure again and again to find the next occurrence for it. So we will ignore it, and then we need to find the next one. For that purpose, what we will do is we can identify the requirement first, because we need to return two positions, not just one, the first occurrence and the last occurrence. For that purpose, if we can see the pseudocode, first we can do the search and find out the position of the element. For that purpose, we can create three variables, like first of all, I will say the first position will be set to -1. It will be directly by default. For example, if we don't found any position, then it will return -1 by default. And then a left variable, because of the keep tracking of the index 0 point of the array. And then the last position of that array ending point, which we'll consider as the right. Then we will keep repeating the loop on from the binary search operation, and find it out the mid position, and if we can found on the left half, we can remember it, or if we can found it on the right half, we can remember it and update it our occurrence. So keep looking for if the left side is less than or equal to the right, then we can try to find the midpoint of it. Once we find the midpoint, then we assign to the statement where it can target our value, means middle number is equal to the target. If this situation is matched, then we will update our first occurrence. For example, we have founded that number, so we can update the variable of that first occurrence, and then we will move our right pointer just before the middle to keep searching, means we need to find another occurrence. Now we can keep repeating this until we find both cases. Like now we can match the case of if middle number is less than target, means if it is less than, then we try to find in the right half to search our target value, and if it is greater than, then we will search for the left half and move the right pointer as before. So once we have done it, we can end of the search and then update the position of the number which is now updated with a particular target we are trying to find. If it is not available, then -1 will be by default a return. So this is the first occurrence. Now we will repeat the same process, step 1 to step 3, for searching the next element, means last position of this array. And once we both found things, and then we will return the first position and the last position, and our target is not found, then we will return the -1. So this is the whole scenario behind it. Now let's deep dive into the code. Okay, let's start implementing in the pseudocode in our code editor. So for left half and the right half, both are repeating as the same. So for that purpose, I need to create a helper function where I can put the logic of the left half, and then the same kind of logic for the right half as a helper function, and then we will return both function as an array and taking the outcome. So I can create a function which is left. Here I will create the two parameters because I need numbers array and I need target. So nums and target. So first of all, I have some kind of variable that can given to me initially tracking of occurrence. For example, I can say first equals to -1 because -1, if we didn't found it, it will return by default. And one for the left hand side tracking and one for the right. So how we will calculate the right? First we will get the length of the array, and then we will do -1 because it will get the last index of the array. Now we will keep repeating the binary search operation on these terms and find the middle point and then the target. So I can say while left less than equals to right, give me middle point. So mid equals to left plus right divided by 2. Now I need to compare this with my target. If nums mid equal target, then it will update the first occurrence because we have found it. For that purpose, we can update first occurrence variable with our midpoint. Okay, then we will move the pointer to the right side. So in this case, our right variable will getting the mid -1 because it will keep coming from right hand side to left hand side. Therefore, we give the minus because it will looking into it. If not, means we can see else if if num mid is greater than target, then we need to check the left hand side of that array. So I can update the left equal to mid +1 because left will keep going like this 1, 2, 3. So it will keep above. Therefore, we can use the plus variable. And when we go from top to down, we can use the minus operator. At the end, we have else, which will return, means if it is not greater then it will be less, so we can say right equals to mid -1, and we will return occurrence because it will be fulfilled. So we have completed the left half searching. It will search the one side of the position inside array. Now for saving time, I can just copy this whole and I can come here and make another helper function, which will be the right half. Same things apply, but just for the first occurrence and the last, here we can use the last occurrence. And then where we updated the first occurrence, now it's time to update its last occurrence and then return the last one. So we created both helper function, which is found in the left and right. It's time to return it, so it will give us the position. For that purpose, I can do a variable where I can save first equals to left half, and I provide nums comma target, and same for the right. I can say last and now I return this first and last. Let's check it. Let's try it once. And, it's a wrong answer. What is two cases are approved, but in one we have finding error. Target. What is it? Output -1 and -1, 3 and 4. So let's step by step reading. We have a variable and return the length. If left is less than right, then it. Uh, if it is equal, then we will update it and we move to the right position. Uh, I think this is wrong. Means we need to first for the left half we will go less than, and if I can see the same pattern, maybe I made a mistake here. Yes, it is also less than. Now give it a try again. Yeah, this time we have passed. So as you can see, and now we will understand the actual big O, how this algorithm is performed as worst case scenario. Let's consider how our algorithm efficient is. I take here the just left half example because for the right half it is also the same. Therefore, I can just demonstrate on the left half function. For all the variable, it will calculate as the constant time because O of 1 will be calculated here. In the loop, it will go as O of log n because it can do multiple operation. For example, it can search for the element and repeat for the left half, repeat for the right half, and then therefore its leading time goes to the complexity of O log of n. And for the inner calculation, we all have just O of 1. Therefore, we can write it here and as a function, whole function, because everything is calculated right now. So our function is returning O log of n for the left half and same for the right half. And if you are familiar with the big O notation rules, where there it must be a thing which we can drop non-constant things, which does not affect that much on our algorithm. We can ignore it and we can focus on the things that can lead too much growth or too much complexity to our algorithm. Therefore, we calculated here all the element like O of 1 plus O of 1, O of 1, and then with the second function. So for the simplicity, if I can cut it down, all the things like if we ignore it all, this all and this whole, so I will come up with the just final solution which will be O log n. So this was the our complexity of algorithm. So guys, that's really it for this problem, finding first and the last position of the element inside the sorted array. And we have learned by breaking down the problem into small, understandable pieces, and then we try to figure out how pseudocode will be applied on it. After that, we write code together and run on the LeetCode platform. And after that, at the end, we try to make it how complex our algorithm is, and we come up with the solution of O log n time, which was required in our problem description. So if you like this video or interested in this, so please let me know down in the comment below. I will try to answer it. And until the next video, my name is Ahir and this was LeetCode 34. Thanks for watching.